Kyle can also record between the two of us. We'll have something. Okay. So let me share the screen. I think I need to just share the whole thing. All right, so this is what you're going to see the first time you start up Visual Studio. And you're going to want to choose create a new project. You can also do this from the file menu, but probably not the first time. So I'm going to click on create a new project. And then you have a choice of different types of projects. We're going to go with empty project. You could choose console app and that might work. The only downside to that is it gives you a, I just realized my video turned off. Anybody know why my video would just spontaneously turn off every couple of minutes? Probably. Oh, look at that. Sorry, give me a second. Yeah, it's not showing my camera. Hold on. Let's try that. Okay. So I was saying that if you choose console app, you're going to get a pre-made file that has some code in it already that you may have to delete some stuff from anyway. So probably best is just start with an empty project. Click next. We'll give it a name. It doesn't really matter what you call it. So there I go. I'm going to create that project. I'm definitely struggling with the trackpad in my Windows laptop. Okay, so here's what you have. The next thing we need to do is actually get a source code file into our source files folder here. This pane over here is called the Solution Explorer. It's just going to have a list of all the files that are in your project. So I'm going to control click or right click on source files. And I'm going to choose add new item. Don't worry, you don't have to memorize all this. I'm just showing it to you once so you've seen it. It's all in the tutorials that you'll get to in Canvas as soon as we get that up. So add new item. I want a C++ file. At this point, be sure to give it the name you want. In the assignments, you'll see that I actually specify what the name of your file should be. So in this case, I'm going to go with a1_1.cpp and then click add. And so now basically we are ready to start typing our program in. You can see that the file showed up over here in our source files folder. Okay, any questions about that so far? All right, so first thing we want to do when we're learning how to write computer programs is how do we get something to appear on the screen, right? So let me just do a quick program that's going to just print something on the screen. Unlike Python, in C++, you're going to have some, you can't just like put an output statement in your program and run it. You've got to have some other stuff in there. So every program that you write this semester is going to have this stuff. And basically, you don't really need to even know what's going on with most of this. You can just copy paste it into your new file and what you'll do, everything here will be exactly the same. You'll just replace this statement I'm about to write with whatever the statements are that you want in your program. So the way we get something to appear on the screen is with the cout statement, and I keep typing on the wrong computer. Okay, so there's a complete C++ program. When I want to run it, I'm going to go to debug, start without debugging, or as you can see there, you can just hit Control F5. That's going to give us a console window with our output right here, the hello world. All right, any questions about any of that? Okay.
This question, this will all be in the tutorials that we'll access later, right?
Yes.
Okay.
Yeah, this will all be in what I call lessons, and also in the textbook whenever you do your textbook. And also I'll have recordings of the lectures, so there'll be lots of places you can get this from. So no need to memorize or take great notes at this point. Just go for soaking in as much as you can, I guess. All right, any questions about the output? Let me just talk a little bit about this statement here. I'm going to give you some details that may not matter much at this point, but it'll be important later on in the course for you to understand sort of what's going on behind the scenes here. Typically, when students first learn about this, they see it and they think, oh, cout is the command, or cout is the action word. That's actually not the case. What's actually going on here is that this is an expression, just like we talk about expressions in mathematics. An expression has an operator, or can anyway have an operator, and then an operand on either side. So if in the expression x plus y, the operator is plus, and the operands are x and y, right? So here in this statement, what we have is the operator is this funny double arrow thing. And then there's a left operand, which is the word cout, and a right operand, which is the string hello world. And so the command, quote unquote, here is actually this operator that's in the middle. It's called stream extraction insertion, sorry, operator. Okay, I'm not usually big on making sure you know all the big fancy words, but in this case, I think it actually helps to understand a little bit about what's going on. Basically, what we're saying here is the stream insertion operator. That's these two arrows here, the double arrows. Yeah. What that operator does is it takes whatever's on the right side, in this case a string, and inserts it into this thing on the left side that is called a stream. So cout is a stream, and you can think of it as representing the console window. Okay, so in this case, we're saying take the string hello world and insert it into cout, which represents the console window. Okay. All right, so if you didn't understand any of that the last 2 or 3 minutes, that's okay, as long as you can sort of do some pattern matching. And if I say write a program that prints your name on the screen, you just put your name there instead of hello world, right? Okay. Next challenge. Let's see if we can add a second line of output here. So I'm going to want to produce this output. So let's go hello. Okay, so I'm just typing the output that I'm going to try to produce now. So here's my first try. Okay, let's go ahead and run that and see if we get what we wanted. Okay, is that what we wanted?
No.
Right, we wanted it to come out on 2 lines, right? So as you can probably guess by now, what's going on here is we never told the computer that we wanted to go down to the next line, and we have to do that explicitly in C++. And the way we do that is with the indel. Just put the word indel there. And that stands for end line. And it's basically like hitting the enter button if you're in your word processor. It means go down to the next line. And typically, it's good practice to just put an indel at the end of every cout statement, unless there's some specific reason that you don't want to have an indel there. So let's try this again and see if that's better. All right. Any questions about what we just did? All right, so let me talk a little more explicitly about what's going on here with the syntax of a cout statement. And let me just say that this is one of those places where a lot of students struggle with getting the syntax just right. And the best advice I can give you is just look at an example, make sure you're following the same pattern that you see in the example. Don't just sort of make up how you think it should look. So here's how it works. Basically, every cout statement is going to start with the word cout. And then you're going to have a list of items that you want to print on this in the console window. Each of those items is going to be preceded by this insertion operator. So I've got cout, and then I say, okay, insert hello world, and then insert indel, end of statement. If I wanted to print something else, say before I hit the indel, I wanted to also print happy birthday. I didn't look at anything to type. If I wanted to print happy birthday in between there, then I would have to add another insertion operator. So it would be insertion operator hello world, insert happy birthday, insert indel. Okay. Any questions? Okay, so next question. Could we, let me go back to our original. Could we get this exact same output with just one cout statement instead of 2 cout statements? The answer to that is yes, right? Because in a single cout statement, we can list as many items to print as we want to. So, and this is where, I see a lot of students doing sort of crazy stuff here. There'll be a semicolon in the middle of the statement, even though we know semicolons can only come at the end. There'll be an extra cout statement in there. And the word cout will appear in the middle of a cout statement somewhere. So just make sure you follow the pattern. Cout, insertion operator, item to print. Insertion operator, item to print. Insertion operator, item to print. So to get the same output using just one cout statement, I'm going to say, oops, it's should hold out here. Um, okay. You guys think that's going to work? If I was in a classroom, I could look around the room now and see people nodding their heads or shaking their heads. It doesn't work here, so I'll just have to plow ahead, I guess. So let's try it and see. There we go. Oops. Whoa. Okay, any questions about that? And so this is probably not a good idea, actually. I'm just doing it to illustrate that I could do it. It's probably more difficult to look at this and see what's going on. So I'm going to go back to what we had originally, which is probably better because it's easier to read and see what's going on. Typically, I would say it's probably best practice and most of the time to set each cout statement in your program correspond to a single line of output in the console window, just so it's easy to keep straight. Okay, if there's no questions, I have one more piece, one more output example that I want to work on. I want to say, oops. I want to produce that output. So here's my first try at it. Basically, I'm just going to copy that and paste it inside these quotations because that's where I want it to go. I can get the track that could be worded. Wow. I may just have to give up on trying to do this in Visual Studio. Wow. Time for a new trackpad, I guess. Yeah. Paste it there. And what do you think? Looks like we have some problems here, right? So the red squiggly means that there's a problem. And you can actually tell by the colors of the fonts here what's going on. The compiler thinks that the string, so we're looking at a cout statement. We've got the word cout, that's good. We've got an insertion operator, that's good. And then we've got a string, but the compiler thinks that the string ends there with that quotation mark, and that was not what we intended, right? We intended that quotation mark to just be part of the string. So in C++, the way we do that, the way we tell the compiler, hey, this quotation mark doesn't end the string, just treat it as part of the string, is we're going to put a backslash in front of it. Okay, backslash is probably just above your enter button on your keyboard. So now you can see that all the strings, apparently, at least in my compiler right now, come out in this red color, reddish color. And so you can see that now the string goes all the way over to here. But we have another problem because here's another quotation mark that we don't want to end the string, right? This second quotation mark from the end here, that's not, our intention isn't that that ends the string. Our intention is that that gets printed on the screen. So I'm going to backslash that one as well. Okay, no red squigglies, that's a good sign. Let's run it, just double check. There we go. Okay. Any questions? So that's called the escape character. And it's a backslash. Any questions about that? Okay, let's move on and let's talk about, we're going to talk about variables and we're going to talk about input. We sort of have, we can't really talk about input without talking about variables, because when you do input, obviously the input goes into a variable. So I want to just clean this up a little bit. Try here and there. Yeah, I'm not doing this again. I'm figuring out a way to just use my laptop. Something's going on with it because it was working fine earlier today. Not fine, but at least I can do what I want it to do. Okay, so let's create a variable that is going to store an int, an integer. Okay, that's how you do that in C++. This is really different from Python, right? Because in Python, you don't have to explicitly create a variable. You just use it and Python knows to create it. In C++, you cannot use a variable unless you have declared it first. And by first, I mean previously in the file. So what this means is, this is telling the compiler to go ahead and grab a memory location somewhere in the computer, label it hours worked, so that we can then later on, we can put stuff in there, okay? Let me just quickly try to motivate that a little bit. Why would we want to force program, I'm speaking as the creators of C++ now. If I'm creating a programming language, why would I want to force programmers to actually have a separate statement that creates the variable instead of doing it like they do in Python? By the way, this is actually called a declaration. And so normally, even though what we're doing is we're creating a variable, we don't use that word. We say we're declaring a variable. So the rule is, in C++, every variable has to be declared before you can use it. And at least one of the main reasons for that is that it helps with debugging programs in some cases. For example, this actually happened to me. I was working in Python and I had an error in my program. And I spent about 45 minutes or so tracking it down. And finally, when I tracked it down, it turned out that I had spelled a variable incorrectly. And there was nothing wrong with that as far as Python was concerned. Python was fine. It was just a different variable. If I had been working in C++, I would have known what the problem was instantly, because the compiler would have just told me, hey, that's not a variable. You can't, something's wrong, right? So that's at least one of the motivating factors behind requiring that variables are declared. Okay, so we have a variable. Now what we want to do is we want to have a statement that says, read something that the user types in and put it into this variable. The way we say that in C++ is cin hours work. Okay, this should look a little bit familiar, except everything is switched around, right? Instead of cout, we have cin, and instead of arrows pointing to the left, arrows are pointing to the right. Hopefully that sort of makes sense why they are pointing to the right, because what I'm doing here is cin represents the keyboard. So it's a character stream that you can think of as being as representing the keyboard. And this is saying, take something from the keyboard and put it into the variable hours worked. Okay, so the arrows basically just indicate the direction of the flow of the data. Any questions? Oh, I was just going to say, in the cout statement, the operator was called the stream insertion operator. So for input using cin, it's the same thing, except instead of inserting something into a stream, we are extracting something from a stream. So we call it stream extraction operator. Okay, extract something from the stream and put it into the variable hours worked. By the way, this is just kind of a quick digression, but if the idea of a character stream feels a little abstract to you, don't worry too much about it. You can still do everything just fine if it doesn't, even if it doesn't feel like you really have a solid handle on what we mean when we say a stream of characters. And typically, you know, as students work with streams, it just sort of begins to make intuitive sense. Okay, any questions about CN statements?
Question.
Yeah.
So if you replaced in line 7, if you replaced cin with an integer or a string, would you be assigning the value to that variable?
No, that's a great idea, but that's we would have to use an assignment statement for that.
Okay.
So the extraction operator, the left operand, must be a stream object. And for now, the only stream object we know about is cin. We'll talk about some more in a little bit later in the course, but at this point, cin is the only stream object that we know about that you can put on the left side of a extraction operator. Okay. Good guess though. All right, so typically, you know, 99% of the time, it's not going to make any sense to have a cin statement without a cout statement first, explaining to the user what you're expecting. That's called a prompt. So let's say cout enter hours worked. Notice that in this particular case, I don't want indel because I want the user to type the value on the same line as where the prompt came out. Okay, so you'll see that in a minute, but this is an example of where you actually don't want, and you specifically do not want an indel at the end of the statement. All right, so we have our hours worked. Now let's do a calculation and print the result. I'm going to say paycheck amount gets hours worked. I guess what minimum wage is 14 now, the most. Anyway, close enough. And whoops, I didn't want the dollars right now. And now paycheck amount is a variable, right? You see a red squiggly there. The red squiggly is there because I haven't declared that, right? If I hover, it'll actually tell me. I don't know if you can, if that's big enough to see or not, but it actually says identifier paycheck amount is undefined. So I'm going to go up here and I'm going to declare it. Okay, looks better. And then I'm going to print out the results. Cout the paycheck amount is all right. Any questions about any of that? Give it a try. Enter hours worked. See how what I'm going to type is going to go on the same line as the prompt. I'll enter something nice and easy to do the math with so we can check our work. Paycheck amount is 280. That seems about right. Any questions? Okay, let me just, I think I have a list of kind of random comments I want to make about this now. Actually, I guess I already said most of it. I guess I would just want to mention, you may notice that I'm being very careful about my variable names here. I think that's super, super important. I could have just used X and Y, but then that would make my program really hard to read. I could have just used, say, hours, right? But I'm trying to be as descriptive as I possibly can with my variable names, because the more descriptive those variable names are, the easier it's going to be for someone else to come along and work on your program, debug it, or maintain it in some way. And that is we're going to talk a lot about that throughout the course, about how important that is. As far as as far as rules for variable names go, variable names can be made up of numbers, letters, and underscore characters. And they cannot start with a number. So that's the only rules: numbers, letters, underscore characters. As long as it doesn't start with a number, you're good. Typically what we do is we use what's called camel case, right? So we all lowercase. So the variable names are going to be all lowercase, except if there's more than one word, the first letter of the second word and the third word and the fourth word and so on should be uppercase. So hopefully it's clear why we would call that camel case. Some programmers like to do it with an underscore instead, something like that. If you are just like super excited about that way of naming your variables, I'm okay with that. Personally, it doesn't work as well for me. I actually spent a few months one time trying it out, seeing if I liked it, and I thought it made my code a lot messier and harder to read. So personally, I prefer to just go with camel case. All right, let me talk a little bit more about this statement here. This is an assignment statement. So that means this guy right here is the assignment operator. It's pretty important, and I think this is the same thing in Python, right? I have not done a ton in Python. I've dabbled, and so I kind of forget things sometimes, but I think it's the same deal in Python, right? It's not an equal sign. So when I pronounce this, I'm going to say paycheck amount gets hours worked times 14. And I use the word gets instead of equals just to emphasize that this is not like an equation in mathematics, right? I'm not stating a fact. Oh, paycheck amount is equal to hours worked times 14. This is a command I'm getting through the computer. Make it so that paycheck amount gets hours worked times 14. So that's your assignment operator there. And notice just another thing to point out here. In C++, all of these statements are all just expressions with a semicolon at the end, right? So in this case, I've got an expression. There are two operators in this expression, right? There's an assignment operator and there's a multiplication operator. And there are three operands. Paycheck amount is an operand, hours worked is an operand, and 14 is an operand. So in C++, most statements are just an expression with a semicolon at the end. All right, any questions about this program? Anything that doesn't make any sense?
I had a question. So in order to do like an actual equals, like in Python, would you just do double equal signs?
Yes,
Okay.
that is correct. Is that also true in Python? For some reason, I can't remember.
Yeah.
Okay. Good. One less thing that you'll have to learn. Okay, I think I'm done with this example unless there's any final questions about it. what I want to move on to is I want to talk a little bit more about the mathematical operators that we have in C++. And then I want to talk about different types of variables a little bit. So, and this is not one of my favorite things to talk about because there's not really going to be a whole lot of action in terms of writing programs and running them. It's going to be more conceptual. But so in C++, we have 5 arithmetic operators: plus, minus, times, divide, and modulus. Okay, so plus, minus, and times, really not too much to say there. Same as they are in mathematics, except that we use an asterisk for multiplication. Also, I think they're exactly the same as they are in Python. Division is a little different. In C++, if you divide 2 integers, you are doing integer division. In Python, you can choose, right? In Python, if you say 2 divided by, like if you do 13 divided by 3, that's going to give you 4.3333, right? So you get a floating point result. If you want, in Python, if you want to get just the integer from this, if you want to just do integer division, you use double slash, right? So if I say 13 double slash 3, the answer is going to be 4. Let's just try that out. So I'm going to say, see out 13 divided by 3. See out 13. Oh, sorry, I'm not in Python. Not sure what I was thinking of. Rewind. I'll just try this. If I run this, what's going to happen is I'm just going to get 4. Okay, so just to say that again more succinctly, if you have 2 integers in C++ and you divide them, the answer is just going to be the truncated integer. And it doesn't round up, right? It's just truncate. So if I have 14 divided by 3, even though that's 4, hope I'm doing my math right here, 4.66667, what's the result is just going to truncate the remainder and it's going to print 4. Okay. If in C++, if for some reason I really need to do floating point division instead of integer division, I can do that by converting one of the operands to a floating point number. So getting a little ahead of myself here, but just to show you, if I put 0.0 here, what happens is C++ says, oh, this is a floating point number. In order to do this division, I'm going to have to use floating point division, and so the result's going to be a floating point number. 4.66667. Okay. The other thing to just point out, since we're here, this is random, but in C++, when C++ prints a floating point number, by default, it prints 6 significant digits. So that's why you have it rounded off to the nearest 5 digits after the decimal point. Okay, any questions about division? Okay, so modulus then, and I'm hoping that you discussed modulus in your Python class, but just to review real quickly, modulus is the remainder. So if I say C out 14 modulus 3, that's going to give me 2, because when I divide 14 by 3, I get 4 with a remainder of 2. And let me just show you, this is kind of tough to do by typing, but hopefully I can make it work. Let me just show you how I would do that. So students often get confused when they're trying to figure out a modulus problem. So my suggestion would be to go back to elementary school, whatever grade it was, where you, the very first time you ever learned about division, and you would do problems something like this, right? 3 into 14. Let me see. The division. Everyone understand what I'm trying to draw there?
Yeah, the long division sign.
Yes, the long division sign. Thank you. That's a good description. I think I'm good there. Okay, so we would say 3 goes into 14 4 times, and then we would say, okay, 4 times 3 is 12. So put the 12 down below. Why isn't it? And then we subtract, right? So we would say 14 minus 12 is 2. And then we say, oh, well, 3 doesn't go into 2. So that means that up here we have a remainder of 2. Right? So I don't know if you even remember those techniques from 3rd grade or whatever it was. But that's how I would, if you, for some reason, you need to figure out a modulus problem, rather than depending on your intuition to be able to get it right, I would go ahead and just work it out the long way like this to just make sure you've got it. Okay. Any questions about modulus? Okay. The trickiest thing here, and this is going to come up in an assignment at some point, I'm pretty sure, is that students forget that division is always integer division if both of the operands are int. And so you just have to, anytime you're going to divide, you need to just like put up a red flag in your brain and say, okay, Dave said there's something I need to make sure I get right if I'm using division and the operands are of type int, and just really think through it carefully. All right, so next question is, what if we need a variable that can store a floating point number? In other words, a number with a decimal point in it. So just like we can declare a variable of type int and then store an int value in it, or int literal. So literal, in case you're not familiar with that term, is just when we have an actual value that shows up in our program. So if I have an int variable, I can store an int value in that variable. Right? If I need a floating point number, if I need to store something like 23.17, then I use a type called double. I'll just use this thing, X. Yes, 23.17. Yep. Okay. So the word there is double. You may see some textbooks or some, if you look around online, you may see people using the word float instead of the word double. For our purposes, that's essentially the same thing. I'm encouraging you to use double for a few reasons, one of which is that, yeah, you get more precision if you use double instead of float. Because a double takes up twice as much memory. That's why it's called a double. But the fact that it uses twice as much memory turns out to be a good thing because of the additional precision that you get. Okay, so a few things about variables of type double. First thing I want to say is that you can never assume that values in a double variable are being stored precisely. So as a result, you should never compare variables or literals of type double, because there's no guarantee that you're going to be storing the exact precise number. In fact, it's somewhat unlikely that you would be. That makes sense? Any questions about it? Pretty straightforward rule. Just don't check to see if two double expressions are equal or one is less than the other, because you could get the wrong result. Okay, next thing I want to say is, if you can, you should always use a variable of type int. Why isn't it exact? It's because of how floating point numbers are stored in computers. Basically, the way they're stored, I don't know, I don't want to go into too much detail, but it's basically like sort of like scientific notation. Like some of the number is stored, and then you store an exponent, so it's 17 times 2 to the 10th or something like that. Because, well, that's how floating point numbers are stored in computers, and it's just assumed that you're not going to use a floating point number if you need it to be exact. I have a fun little program that I could show you that demonstrates this. I don't think I want to take the time to put it up here right now, but basically I could show you a program where I take 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0.1 and do that 10 times. So I'm expecting the result to be 1.0. But when I print the result, it turns out to be something like 1 point and then like 12 zeros and then some numbers. So, 1.000000009764, something like that. So anyway, bottom line, what you need to know is they are not stored precisely exact, and so you cannot compare them. Okay, next thing I want to say is, partly for that reason, you should always use an int variable when you can. So if you are storing something like that's counting objects or something like that, don't use a double to store it, use an int. Next thing I want to say, I'm just kind of going down a list of random stuff to say about floating point literals and variables here. In C++, if I say cout 5, C++ interprets this as an integer. It's an int literal. If I say 5.0, that is not an int. That is a double. Okay, so it's a little bit different from how we would view it in mathematics, right? In your math class, if your teacher asked you whether 5.0 is an integer, you'd say, well, yeah, 5.0 is an integer, right? In programming, or at least in C++, it's not. 5.0 is not an int, it's a double. Any literal that has that decimal point in it, the compiler is going to treat it as a double, not as an int. May not be clear at this point why that would matter, but just put that in your toolbox because it'll come up with. All right, there are going to be times when you're going to need to convert an int into a double. So let me show you a couple ways to do that. If the int that you need to convert into a double is a literal, like in this case, right? So let's say that I have this literal 5 here, but I need that to be a floating point number for some reason instead of an int. I can just throw in a 0.0 and voila, now I have a double literal instead of an int literal. It's a little more complicated if the thing that I need to convert is an int variable, okay? So let's say I wanted to say, I want to print hours worked, but I want to print it as a floating point number instead of as a literal. So right now, if I run this, it's just going to print the number 7, right? Let's try it. Okay. So there's my 7. Let's say that I want this to be printed as if it were a double instead of as if it is an int. So here's what the syntax for that looks like. It looks kind of scary, but it's actually pretty simple, and you just copy paste. You don't have to worry about what the words mean. There is the preferred syntax for converting an int variable into a double variable. So if we try that, oh yeah, well, so it's printing it because C++ only doesn't print a decimal by default. It's looking like an int anyway. So you'll just have to take my word for it that it's actually converting it into a double. I could spend 5 minutes setting it up so that you could actually see the difference, but I'm hoping that you could take my word for it. Okay. Let me talk a little bit about what happens in C++ if you mix up ints and doubles in the same statement, okay? It turns out that in C++, you cannot have an expression with an int operand on one side and a double operand on the other side. C++ doesn't do arithmetic with 2 different operand types, but C++ will automatically do a conversion and make it so that the 2 operands are the same type. So let me tell you what the rules are for that. So rule number one has to, well, number one has to do with expressions. Okay, so for example, if I had 2 plus 3.5 divided by 5. Okay, I can do that in C++, but what's going to happen is C++, if I have an expression where one operand is an int and the other is a double, as is the case here, what C++ does is it converts the int into a double first before it does the calculation. So what I've got here is going to be 2.0 plus 3.5. And so that's going to result in 5.5 divided by 5. And then C++ is going to look at that and say, wait, I can't do that because the left operand is a double and the right operand is an int. So what I'm going to do is I'm going to convert that int into a double first. And then I can do the math and it comes out to 1. Any questions about that? Okay. Rule number 2 is about assignment statements. Let me just say assignment. So if I have something like, let's say I have a double variable in X, and I set it equal to 5. C++ is going to look at that and say, wait, I can't do that. X is a double variable. 5 is an int. So I'm going to have to first convert that int into a double, and then I can do the assignment. So the rule for assignments is C++ automatically converts the value on the right side to match the type of the variable on the left side. And I actually forgot to write down rule number 1. Rule number 1 is if an expression has one int operand and one double operand, the int is temporarily converted to a double. Okay, and really I should say, we're talking about arithmetic expressions here. So I'm going to say if an arithmetic expression has one int operand, one double, the int is temporarily converted to a double. All right, any questions about any of that so far? All right, so I'm going to stop there with the content. We're going to talk about logistics just a little bit. I'm going to go ahead and stop recording.